So I've decided to solve some problems and make a video at the same time. So I have chosen this list posted by Blind. So I will try to try to do all these questions, all these 75 questions over Leetcode. We might do some practice questions or so. Uh, what I'm thinking of doing is basically how I approach the question, and I would try to limit myself with a timer. I will try to do it as fast as possible. So first I'll do it however I feel and however I can, and then if I am not able to solve, I will search for the solution and then solve it. So in the video, uh, at the end of the time, in the description, you will have the timer where the exact solution or solution starts. But before that, it will be just me solving this question in whatever way possible. So you can watch if you want, or you can jump to directly to the solution. Before that, I will try to solve this live on camera only, on screen. So yeah, I will also be following this set of rules or tips while solving the question, so that I am doing correctly all the steps correctly. So these are the 75 questions. Let's pick this first one, which is two sum. Okay, and we have, okay, this is the question, and we have start the timer. I'll be doing or explaining things that I'm writing on my paper, because writing in paper is advised. So question: given an array of integers, return indices of two numbers such that they add up to a specific target. So you have given an array which is of integers, and we need to return index of the two numbers that add up to a specific target. Okay, I think this is the target we have given, and this is the number of the enums array we are given. So you may assume that each input would have exactly one solution. Okay, and you may not use same elements twice, and not use same elements twice. So I think, so if I take example as, suppose if they're saying there will be no two elements, so then that's, we can say this sorted. If it's sorted, so 1 2 3 4 5 as an example. And suppose if I have a target t of value, suppose 6, then the only possible, not only possible, okay, 5 1 6, 5 1 is 6, and yes, 5 1, only possible solution is 5 and 1 is 6. Not okay, there's also one solution will be 4 and 2, so that is also a solution. So they are saying that there will be only one solution. Given an array of integers and need to number and integers, you may assume that each input would have exactly one solution. So they are saying that it will have exactly one solution. So in this case, if we have 1 2 3 4 5, then it should be there, 4 should not be there, or either 2 should not be there, because they are claiming that there is only one solution of that. Let's see, in the examples given, we have given 2 7 11 and 15. The target is 9, so 7 and 2 are the only solution, and there are no other solution, because 0 and okay, this is correct. Accepted 2.6 million people has solved, and out of 5.7. okay, cool. Okay, there are hands as well, cool, didn't know that. Nice. Compare the companies, you don't see companies. Okay, the question is very easy, one of the easy ones, because I think it's, yeah, it says easy. So we are given an array of integers, and we need to return the two numbers which add up to the sum. So one solution that I can think of is just traversing the whole array. Suppose we have an array of, let's me write there 1 2 3 4 5. So okay, well, 3 4 will not exist. Let's take their example only, 2 7 11 and 15. So we can traverse from linearly. Array is in sorted array, but it could be possible it's not sorted because question does not mention that. So suppose it could be like 2, 11, 15 and 7. That could be possible. So if it is sorted like these 2, 7, 11 and 15, then we could just traverse the first element, okay, and then like first pointer at the first element, that is 2, and then we have another pointer which goes through all the remaining elements, which is 7, 11 and 15, and checks if we add 2 with some of them else, then will it be equal to the target. So if it pick 2, then we traverse through the array, so we get 7, we get 11 and we get 15. So when we get 7, we get okay, this is equals to 9, so it solves the problem. And in case of 2, 11, 15 and 7, in the second case here, so in the second case we can see we first choose 2, then we traverse to 11, we go to 15, and 15, 2 is not target, and 2 and 7 is target. So I think we can do it in linear. One thing we're not sure that is, if it is sorted, then we could actually use binary search, because then if I have suppose 2, then in this array I can do binary search. That is one solution. So if I do, for now, if I do just the uh, linear solution, which is just get first element and then traverse through the whole array, and then if the so that will be an n square, not linear, because suppose, okay, why it's not linear, suppose this is the case 11, 2 and 7. So let's say there are other numbers in this. Okay, so now if I pick 11, then the only solution are, let's say, 2 and 7, which are at the end of this array, and all these numbers are gibberish number, which let's say are valid for this input. So we would have to travel. So if we pick 11, we will have to pick all these elements. Then we pick 15, then we will have to again traverse the whole array. So in this element, then we would have to again pick this whole array. So we will have to do an n square uh, iterations. So let's do the n square first. Okay, that's a bad solution. Let's implement the brute force solution. So how would I be doing that? Let's first rename the array of nums is, let's a, and then target, let's t. Okay, I don't know if I want to change this to Monokai, I guess, or was it better? I don't know, let's see. So after that, what I would want is just loop through the whole array and get the target sum. So we'll have for loop for int I equals to 0 as smaller than a dot th length I plus plus, then for, and let's tell int j equals to, now j will have to start after this. So suppose 2, 3, so j would have to traverse from 7, not from 2. So will be whatever I plus 1. J smaller than, again, a dot length and j plus plus. Okay, so we have traversed the whole array. Now we want to get the sum. So if I can say if the element f a, so we want to return something. Okay, we want, okay, that we didn't saw. So we, oh shit, you forgot to, let's read this. Clarify question. So we failed from the first point as we didn't remember to how the return type should be. So we need to return actually the indexes, which was already mentioned here. Okay, cool. So we need to return the indices. So let's again follow this. Read the question, we read this. Clarity of understanding of the inputs and outputs and the side effects. Okay, let's talk about input, output. Let's talk about side effects. So input and output. Input, we clarified the input. Input is an array and the target, and output is an indices, array of indices, which will be having just two elements. So you can say it is an array that an array we are returning will be 1 cross 2 array, which is 1 row 2 columns, as you can see here. And then the side effects. So what could be the side effects? The side effect could be like, I think, edge cases. If it's talking about, I don't know if it's talking about. Search, what is he talking about? Side effects. Okay, I think side effects is edge cases. So if it's about edge cases, so array can be null or empty. So this can be, say, you can say that what if you got an empty array? What if you got null array? Null point null okay, null array, let's say null just as an array. Okay, there's a null object. And if we t, so t could be minus negative, but I don't think that will be a corner case to handle. Doesn't matter. So that does not matter. So now let's see, go through the example to ensure the understanding of the problem which we have now, I think, and spend as much as time as you need to understand the problem. This is important. We have understood the problem, and now try to think an algorithm to solve the problem. Try similar but less complicated problems. Okay, so for the algorithm we have got one algorithm. Actually we found two algorithms. One case is if it's sorted, then we can use binary search. I think I should change this. Blackboard. Okay, Blackboard, it's way more visible. And unsorted, we can just use often like two nested loop, basically nested loop. Okay, so this is the approach. So let's okay, then we have actually I didn't start it. Okay, I started. Cool. So go to the example of the, then try making attentions to your process and manual looking work through example. Okay, we did this. Discuss time space complexity. We are discussing it along the side. We are solving the question. So if you can think of a better algorithm, we can have time. And you have time. Go to the step 4. Okay. Otherwise, ask if this is the good, and if it's not, go to step 4. So okay, we are implementing a brute force solution for now, which is kind of not recommended, but let's do it. It's not like recommended. We have to ask the interviewer, but there is no interview for right now here. So we ourselves are our own interviewer. Yes. So yeah, this looks very old. Let's again back to Molokai. Just okay, that's better. So we have a loop, two nested loops. Now in this loop I can say is if the array element, if the array element at array I plus the element at array j is equals to the target element t, then I think we have got our answers, and we can break the loop, or we can break the outer loop as well. So let's say outer. I don't think it's a good practice to do this, but let's do it here. Or we could just use another variable here to break the outer loop, but I think it's a shorter code. So if we found this array, we just go to break outer, and as soon as we have okay, but we need we need I and j as well. So we should define int I 0 and j here. That will be better. So now we should not okay, now I and j are incremented, and as soon as we break, we got the I and j. Now we need to return the new array, a new integer array with value as I comma j. Is that correct? In the case of 2 and 7, we are sending 0 and 1, which is this and this. So I and j should do the job, and plus let's copy them outside. I have to just with this. Okay, let's handle the corner cases. If it's empty array, so if a equals to null, if b equals to null, or a dot length is not equals to 0, will return an empty array. It's new integer array. Empty array or null array, both are handled. So if the array is null, then it will true, and it will be true, and it will go inside it and return it. So if it's not null, then it will check another condition. So then it will check the length of this array, and if its length is 0, then also it will return an empty array. Otherwise, we are initializing this ing here. Let's do one more indentation just for the sake of this. Cool. And j, and we are an outer array. So now outer array I is going from a to a dot len, which is from 2 to 15, and then incrementing I. J is going from I plus 1, which is 7 to 15, I plus 1, and j plus plus. And for each of them, we are checking if the elements at I and j at any point of time are equal to the target we are looking for. If it is, then we break the loop, and now I and j are already having some values. These I and j will use as the for the creation of this object, and let's try to run this code. Okay, I think this should be a syntax error. New integer array of j might not have been initialized. Okay, there are this case j would not be initialized. Let's initialize them. I think what is the case though? So in case of I, we have j. In the case we did not found actually. Suppose, so let's initialize them with -1, not 0. Let's initialize them with -1. Okay, I will be initialized for sure, so it doesn't matter if we initialize I or not. But j count. The reason why j could not be initialized is because suppose array was empty, which we already have handled here. Suppose the array was empty, so I is equals to 0 and a is smaller than length. So I 0 is smaller than 0, which fails. So j will not be initialized, hence this causes a compilation error, which is not the case as we have handled the empty array scenario. But then also suppose there are some there is some case. For that we have just put here -1, and which will not be true as j will for sure go in this. Okay, so let's with this. Okay, we have accepted this case 27111. Okay, so we can submit, but I would like test it again for another feature, another test. So let's try the test case. What if that's 7 is not here and 7 is here? It should work. And run code. Let's run the code. And we can test for suppose 1, 2, 3, 4, 5. In this case, we have actually two scenarios of having 5. I don't think we should, or having 6. I don't think we should test this because there are two solutions for the same problem, which our questions does not specify. It says exactly one solution. So let's submit the solution. I think we would get a TLE here. Okay, we did not, but our solution I think is not the best. Let's open a new tab. So yeah, we are actually having a very bad solution, which is just 25% of the in the graph. So we could do better. Let's now do better. So this is an O of n square algorithm. Now let's take it off. Let's just remain with the condition here. No. So first of all, I'm not sure if this is an sorted array or not, because if it is, then we can use actually binary search to find the array. So example, if we have 1, 2, 3, let's take a bigger example. No, this example 2, 7, 11, 15, and then 29, and 7 is suppose somewhat here, and 2 is also not here. It's 0, 1 and 2. Okay, so we'll go for, we pick 0, and then in this whole array we will search if we found 7 or not. Even we can search in this whole array including 0 as well, because any number is not present again. No, this is not what it guarantees that, okay, we should not search. We should only search in this array, and this is the sorted. Okay, this is not sorted, so I have to make it sorted. So yeah, no, we can pick 0, and then we search for that if t exists in this, because t minus 0 is t. So then 1, if we pick 1, then we can need to search t minus 1, that is if t minus 1 exists in this array, then we got the solution. Then if 2 pick, then we will need to check 2 t minus 2. If t minus 2 exists in this array after 2, then we got the solution. So this is one possible solution, but for this we need to be sure that the array we get is a sorted array, which the question does not specify actually here. So if we use sorting, then we can have a algorithm of O of n log n, not n log n actually, n log n, because n log n is the time. Okay, it will be n log n, as so log n will be the time, log of n will be the time taken for the search. So in the array, in the array, where is that? So in the 1 2 3 4 5, this is a sorted array, then the time taken to search an element in this array will be log of n, which is log of 5 here. So, and we would need to traverse the whole array. So in this array, then we traverse this array. So for each of the operation we are doing searching. So in that case, it takes n times log n, which is n log n, which is also complexity for this sorting algorithms. Now, so I'm not sure if that this is a sorted array or not, which we also cannot check, because we would need to have all the data sets, all the test cases that Leetcode checks on. So another way we can do this question is, I think, hash maps. So the solution that we did was, which was O of n square solution. Okay, and the hash map, if we use hash maps or some kind of set hashing, so we can do it in O of 1, which is constant time, but it will take actually memory. So let me explain. So what we can do is basically, so we have an array of 2 7 11 and 15. Okay, so if it is a random array, we are assuming it's a random array because they are not given. So what we can do is, we can put all these elements into a hash map. Okay, we could use set. Okay, could use set. We can use actually set. We can use set because even if 7 occurs 2 times, and okay, there's a corner case though. And using hash map and sets, the reason is, suppose, okay, so if suppose my target for this set is 9, then we know there is only one solution, which is either of these 7 or 2. Then our set works. So what is property of set is, it will have all the unique elements. So even 2 11 15 7 7, it will have just 2 11 15 and 7. So it will not have the duplicate 7 here. Now this arises a problem in case if we are, suppose here, if we are having this whole set but the target is 14. So now you see the problem is, if we look into the set, we have only 1 7, so we cannot determine if there was another 7. So n square solution, in the n square solution, this was not the problem. It will check all the elements that present in that, so that will not do any problem. Okay, you may assume that each input word have exactly one solution, and you may not use the same element twice. Okay, actually you may not use the same element twice. They gives that they are not using same element twice, so that means this case is not valid. So if this is the case, then I think we can use hash map. So if we have hash map, we get first element of hash map and we look up in the hash map as of 1. So suppose in the case of 9, we have 9 and we go and look up 2 in the hash map, so we get 2. Then means we need so if we subtract 2 from this, 9 minus 2, we get 7. So that means, okay, if I choose 2 to be the first element, one of the elements out of the two that we need to get, so the other element's value should be 7. So if I could find 7 in this whole set, that means I have found the pairs. So let's implement this solution, which will be an O of n n solution, because O of n solution, not constant, because O of n is because we would have to actually look through the whole set, at least up to the n minus 2 elements, as we are guaranteed the solution. So its complexity will be O of n, but its space is also O of n. So let's create a hash set. Let's create a just set. We don't need actually hash map, so let's create a hash at hs hash set hash set of integers set is equals to new hs hash set. Okay, I need to set all the elements in this. So hash set from the integer for integer a from a set dot add a. Okay, we have got all the elements into the set. Now we can traverse this set for v from this set. Okay, then, and in this set we just check if, so if now we have v, so what we need to look is t minus v. If t minus v is in the set, then our job is done. So if set dot 0 and 0 o and tas contains t minus v, if that is true, okay, shit, there's another problem now that we have did not look through. Now I realize, okay, if we set, we could get the elements that are there, but the issue will be the indexing. Okay, if I use a set, I know what is the element. So I know if I have this element is, if I have the first element that I get here, suppose this is example 2 7 11 15. So if the first element I get 2, then I need to check if 7 exists in this, which set will provide me yes, 7 exists. So it means I got the answer that 2 and 7 are the numbers, are the pairs. But then the issue is I know I don't need just 2 and 7, I need the indexes of 2 and 7. So now either I would have to take these 2 and 7 and iterate through the array again and again 2 times to get the array, or 1 time just to get the indexes, or I can use some other different way. So what I'm thinking is set can store just the one value. So we could actually use hash map to store both the values. Now if I use hash maps, so in hash map we have a key value pair. So key could be actually the value, actually this data, and the value could be just the index, so that we have indexes for both of them. So let's do that. I think hash set will not be that much better. Okay, let's do hash map then. Let's just convert this to, let's rewrite again everything. Hash map of we are losing time. Okay, I think I can implement in 7 minutes. Integer comma integer map hash map, then for int a and the I just map dot put the first value a and the index of this, which will be 0, because not 0, sorry, we are kind of guaranteed that it will be sequential, so I can say it will be I plus plus, which will be I for the first scenario, which is 0, and then it will increment this value, so next time it will be 1. After this, what we can do is, now I just want to read them. So for hash map, reading a hash map, now such a we don't need to actually read the hash map, we just can again read the array for a from a. Okay, if I think there's a better way to do this here. Okay, I will try to do this, but let's submit the solution before. So if a not what I want to check, if map not c1 TAINS contains key, and the key is t minus a. Now I need to check for t minus a. If t minus a exists, then we have the answer, and map dot contains key. If t minus a exists, that means this I've got the answer. So what I can do is, now I can break, or I can return, actually I can return ITUR and return an empty array, new integer array. Now the actual values will be for the a. I know the index of a. Do I? No, I don't. So I can replace this for I equals to 0, I smaller than a dot let length and I plus plus, and then I'm doing very badly and I am not thinking beforehand, I'm just coding. Okay, map contains t minus the value at array of I. Now okay, so now index will be I comma, now we have got the value of this, so we can get the value map dot get what is t minus a of I. This is the value that I got, so the result of this will be, this is the key, so it will return a value here, and that value will be the index. Okay, and if it does not, suppose this for loop does not, then return an empty array. Let's copy from here. If it does not, okay, let's check if there's a bug. So this is correct. Now I have created a hash map of integer. That integer is for the value of the array, which is these 2, 7, 11, or 15, and this corresponds to the index. So create an integer I is equals to 0. So I'm traversing through all the elements in this, so 2, 7, 11, 15. So I put 2 with the index 0, 7 with the index 1, 11 with index 2, and 15 with index 3. Cool. Now I'm again looping this. Okay, this is a problem. This is I and this is I, so there's an issue. I should make it J, and here also J. Got a bug. So for int I equals to 0, I could just use same I. Cool, no problem. I is more than length, I plus plus. So now if the map contains the key, and this is the important part, t minus a value, because a has the, we are iterating the array, so if timer, cool, and then return the integer array of this t and I, and that's the index of the first element, and the second element is get from this. Let's try to run this. I think it should work. I'm not seeing any case which would fail it, because we only have 2, all the elements are unique, so it should work. Let's say okay, it didn't. So what is the case? 3 to 4 and 6. Target is 3 to 4. There was no 4 to us, should be. I'm going through first element. Why didn't this solve? Why did this work then? What is the reason it didn't work? 3 to 4. So if we see 3, so map will have 3 to 0, 2 to 1, and 4 to. So if you see the map, it will be something like 3 to 0 and 2 to 1 and then 4 to 2 basically. Now in this array 0, I pick 0, and then I check if the map contains the value, which is 6 here. The t is 6 here, so I check if 6 minus 3, which is 3. So if the map contains 3, which is okay, this is the problem. I got it. So 6 minus 3 equals 3, and it checks the whole map if 3 is in this map or not, and it takes this whole same array as this array. So I have a small hack for that, I think. So we can check if the difference is same, then not the hack will not work, will it? Because 3, we are saying that if t minus a is 3, so the another element cannot be duplicate. So if t minus a of I basically is equals to a of I only, okay, then I think we can continue securely, because we know that we don't have duplicate elements in this. So if I got 3 and I will not be able to find another 3, so that will be a duplicate. It's kind of a hack. I think there's a better way to do this. I will do that better way. So this will prevent this case 3, and it will go in the next loop, which is 2, and then it will check for 4, which will be fine. So let's submit this code. T minus f(i) is equals y. Continue. Cool, it should work. Right, it didn't. Okay, we have, oh shit, let's have a 5-minute timer. 5 minutes, 3 minutes, TIMAR. Okay, start, sorry. What is the issue now? What the heck? They were saying there's been no duplicate elements in that. Whoa. They specified na here. You may assume that each input would have exactly one solution, okay, and you may not use the same element twice. What does this mean? You may not use the same element twice. Okay, it means I guess duplicates are there. Okay, you cannot use the same elements. Basically, you have 3. Suppose you have also another 3 in this example of this case submissions. This 3 is 3. So now you can have you can pick these differently. This 3 is the first, yeah, and then the second 3 is this one. You cannot do this 3 and this 3 like the same thing. You cannot choose that first 3 twice. Okay, now it is a bit difficult, I think, because now hashing will not work. Reason, we have duplicate values, so hashing will not have duplicate values. You cannot have duplicates in hashing, neither in hash map and nor in our sets. Then what we can do? Okay, there is a solution. Okay, I think there's a solution called meet in the middle, because your hashing will not work even if it's even in case of duplicates. I think it's not a good idea to use binary search, because it's not guaranteed which. So you have, suppose, two. So in this case, if you search 2, you're not sure which. Depends on the implementation what you do. Okay, in this case, okay, you'll find obviously 2 is here. Suppose just everything is fine, 2 4 5, and so now in this case, if you are searching for 2, you're not sure which 2 you will get. Depends on the implementation. You could get this 2 or you could get this 2 as well. So binary search and binary search fails because binary search and both, I think, I can generally say, if case there is duplicacy, if you can write, I am writing duplicacy KC, then binary search and your hashing kind of sucks because you cannot use both of them. In case of binary search, the reason is that you are not sure which element it will give. Not sure of the index. Get. It depends on actually the implementation. Now, in case of hashing does not allow you to have multiple values, duplicate values. You could have, I think, in multi what do you call them? Multi-value hashes, I think, but this is not part of Java. That is external libraries. Hashing does not allow you to have multi-duplicate keys. And in this, duplicate are basically keys. We cannot have duplicate keys. Values can be duplicate. Values does not matter. The key is the what that matters, because keys are what are hashed in the maps. So okay, this solution fails actually. We cannot actually use this solution. Hashing fails, binary search fails. Now, the another solution that I can think of is meet in the middle. So, but that solution also kind of works in a sorted manner of array. Kind of sorted mannered array. The reason I'm telling this array, the reason is this, because what you do in meet in the middle kind of algorithm, suppose you have 2 3 5 8, shit, this timer again, I think it will take more time. Let's reset that. Now I think I've done my side of solutions. Now I would actually see solutions, and let's move on. So yes, mid in the middle algorithm, what we do is basically, so this is the example. So 2 3 5 8, then you have 9, you have 10, you have 13, suppose 16 and 17. What you will do is, you could have duplicates in this as well. I think it doesn't matter, it does not matter much. Okay, so 2 3 3 5 8 8 9 10 13 16 and 17. Okay, now you will have one pointer. You can say meet in the middle, or you can say two pointer as well. So one pointer will be on this side in the beginning 2, and the second end pointer will be on this 17 actually. So now you can say suppose you need to make this sum. So your target is 9. Okay, so if you add this and this, it will be a huge number. So you want to actually decrease this number, so you will decrease this pointer actually, because if you go backward from the right direction, as this is a sorted array, so the number will keep on decrease. So you'll go to 16. Now 16 to, still the number is very big, so you go to back to 13. Now still the number is very big, you go to 10. Now still the number is very big, so you go to 9. Okay, now okay, then you can again go, you will again, sum is still greater than 9. Your target is 9. So see, your target is 9, not to get here. Your target is to achieve a sum 9, I think, which is not possible. 5 6 7 8, no. Okay, let's start change our target, because 9 is actually not possible here. So your target is suppose 5 and let's say this 3, or let's say 8 and 3. So the target is 11. Okay, or you can say 10, because 8 and 2 can say 10. Let's do 8 and 3, which is 9. Sorry, 11. So now your target is to reach 11. So 9 and 2, 9 10 11, which is actually just this what we need actually. Okay, so we got actually 11, 9 and 10 11. So we got the 11. Suppose let's change our target from 11 to suppose 10. So 8 and 2 will be 10. So again 9 and 10, 9 and 2 will be bigger, so we'll change and come to it, which again solves the problem. And suppose we want let's say 8 and 5, which is 14. Okay, it's 14. uh, yes, is it 9, 9, 10? So now we want 8 and 5. 30. So 13. Now if we want 13, we would say 8 and 2, which is now 8 and 2 is smaller actually. 8 plus 2 small, so we will upgrade this one now. Instead of this, it is already in 10, and then we will again say 8 and 3, which is still short, so we'll again increment this to 3 and 8. So we get it's still short, then we will again increment to 5, and we have 8 and 5. So now we reached our solution. So this is what the solution is. So I think we can use this solution here. Okay, we can have pointers, but it still kind of assumes that this is a sorted array, which I'm gonna assume, or can I assume? Let's say check out some hints. Similar questions are this. Okay, they have some similar questions, which is nice. Okay, that is really cool actually. Similar questions are important, I think. Very good. Then we have show hint. So a really brute force way would be to search for all the possible pairs of the numbers, but that would be too slow. So but this is what we did actually in square solution. We found all the pairs. Too slow. Again, it is the best try to try the brute force solution for just for the completeness, which we did. It is from the brute force solutions that you can come up with a optimization. Cool. Now if we have show hints, so hint number 2 is, so if we fix one of the numbers, say x, we have to scan the entire array to find the next number y, which is value minus x. Correct. Now where value is the input parameter. Yes, can we change our array somehow so that this search becomes faster? Need to change this array. Okay, let's think about this. How can we change this array to make our search faster? First, if array remains array, we could sort it. That is the only thing I think. But if array becomes something else, then we could use hashing. And if it's not even hashing, then okay, if we are not using hashing, stack queue is not the solution. Binary tree vagera is also not the binary tree. I don't think this is an easy question, man. I think it can be solved using hashing, just with a different implementation, because what we did in our implementation was actually we just first put all these elements into the hash map. Okay, and then in case of duplicate we had only one kind of number, and so we were stuck because we had just the all the unique numbers. So in case rather than implementing this way, what we could do actually is, okay, let's first check 2 and then check in the hash map if uh, what corresponds to the 2 for getting the answer. This is 2, so target minus 2 is present in the array or not, sorry, hash map or not. Then it's not present, so we'll put 2. Then suppose 3, we pick 3. Now we check 3, t minus 3 is present in the hash map or not. If it's not, then we put 3 as well. So now in hash map we have 2, we have 3. Now we can check 3. Now in this case, if we 3 checks 3 t minus 3 again, so if t minus 3 is not the answer, if t minus 3 is actually not 3, then we will not find it in here. But if it is t minus 3 is 3, then we find 3 already in the map. So this 3 and this 3 will be picked. So we get the solution. We get a solution there. So hashing could do that. In this case, it will also solve the duplicacy problem, because if it is duplicate, then it doesn't matter. If that duplicate doesn't contribute to our answer, then it will be overridden. So suppose in this case of, let's in the third case when we choosing this 3, so and we do t minus 3 and that t minus 3 is not equal to 3, so we can put this element into our hash map. So we'll just update this 3, or you can even let it be there. You choose to update it or not, it doesn't actually matter. So it's on 3. Now we go to 5, and then we will check t minus 5, and if t minus 5 is our answer, then if t minus 5 is present in these two elements, then it's fine. If it's not, we insert 5, then we go to 8. So it's the same case in 8. So we pick this 8 and we check if t minus 8 is t minus 8 is present in this array. If it's not, we put 8, but if it is, then we just get the value out of it. And I would suggest not to update the value, because in case we want indexing, so it will be the indexing of the first one. Okay, I think we got the solution. Let's again implement the hash map solution. Hash map, a map of integer comma integer map is equals to new hash map of tk. Okay, cool. Okay, then we need to now, but in this case we'll not be putting all the value in single go in the map. We'll just traverse this array for int I equals to 0, I smaller than a dot length I plus. Then we want to check if our map dot contains okay, that contains the key okay, contains capital key. Now the key is basically the target minus the value of array that we are in on. If this is contained in the array, that means we found the values. We can return the new integer array with I comma the value we get map.get for the t minus ai as the key. Okay, but if it does not, then we need to actually, else if we did not find it, then we would need to put it in the map. So map.put, okay, map.put. Now we need to also see, okay, we are putting the value. Let's put I the value at index, put value ia of I at index I comma. Now in this case, if we do it like this, so it will actually override our case which we are talking about. So suppose we again had 1 2 3 comma 3. Now 3, let's first 3, this 3 was picked, this 3 is not in the answer, so we in the map we inserted this 3 as well. Now we are on this 3, and this 3 again is not the answer. Suppose target is t is equals to 9, so 9 minus 3 is 6. We want 6, but 6 is not in this array, so we'll put this 3, so which will actually update this. So here we are actually updating this, which we don't want to, so we need to check again. We can have a check if which I don't think will make a much difference, because if this was the answer, then we would already have gotten the answer. Okay, but in case of duplicate answers, we would have the first duplicate at its right index, so it will not matter. I don't think it matters. And so we will put this solution if it is not there, and finally we will just traverse through whole array, and if it did not found, we could just return this whole empty array. Let's run and check. Okay, we have a new hash map. Not the issue. Let's not look here, and let's try to figure out hash map integer spelling is correct. Hash map, new hash map. New hash map. Okay, the spelling is wrong. Okay, I found that's not wrong. Okay, this works. Now let's check the previous solution. If you remember, we had failed a test case with 0 comma 3 comma 3. That's 3 comma 3, and the t was 6. So in this case we should get 1 and 0, sorry, 0 and 1, because we got getting 0 and 1. 3 was the case, which was somewhat this should work and it should be efficient enough. The time complexity, space complexity of this solution will be O of n. Let's look at our solution. Yes, so we are at 99.90, which is good enough. Cool. Let's reload to get our solution. This is our solution. Where's our previous solutions? Okay, this is just particular, so we can see our previous solutions here. Previous solutions, summations. Okay, these are the summations. Okay, cool. So let's this is the solution. Let's look at the solution that they provide. Okay, so first is the brute force approach, that is the same with that we did. Or you can have throwing an exception. Okay, then you can throw exception as well. So there is an O1 solution with the complexity of O of 1. Then there's a 2-pass hash table. This is, and then there's a 1-pass hash table. Okay, I think what we did was this, and what they are doing is this. Let's see this solution. So to improve easy to read for everybody. Okay, I cannot do this. Let's just read this. So to improve our one-time complexity, we need a more efficient way to check if the complement, because if the complement exists. By complement they means just, okay, by they means just t minus the value we are searching, t minus I suppose. So exists in the array. If the complement exists, we need to look up its index. That is correct. Now what is the best way to maintaining a mapping of each element in their array to its index? That is a hash table. Correct. Now reduce the lookup time from O of n to O1, which we did as well, but trading spaces for the speed. Yes, this is important. So even our algorithm is O of n, now we have we searching is O of 1, but now the space to hold all these elements becomes greater, which is O of n, because O of n there are n elements in the hash map. Maximum there could be. So a hash table is built exactly for this purpose. It supports faster lookups and near constant times. Near constant times. As in near, because if collisions occur, lookup could degenerate to often times, which is hardly there are lookups, hardly there are collisions, because the algorithms are very uh, distributed. So, but yes, if collisions occurs, there's O of n time complexity, and there is a way how we can handle collisions. So you could actually add handles collision to your learning. Handle collisions in hashing, both in table and map, same things. But lookup in hash tables should be amortized over one time, as long as the hash function is chosen carefully. Yes. A simple implementation uses 2 iterations. In the first iteration, we add each element's value and its index to the table. Then in the second iteration, we check if the element's complement, this is target and m, exist in the table. Beware that the complement must not be num itself. So yes, we did exactly the same thing, but the problem was this: the complement must not be the num itself, which we handled by a hack, but it will not work, because in that case we had 2 3. I think there's a good hack if you could use. You should have used a better hack. So what they are doing is the same thing. Okay, they have this they put all the elements, and then this yeah, this checking this. Now they take out the complement, which is this target minus num, but they have something going on here. So they check if the target, the complement is present in the key map or not, and then they also check uh, the index of, okay, they're just checking the index. You could do that as well. If that is the case, then you could return. So if their index is not the same, then you could have returned this, but I think our approach is also good. So this is 2 times we are going through the array, 2 pass hash table. But yeah, this is a good that we are just checking if the last the element that we are right now is not, even if it's present, but it's just this, they are not same element. So in the case of time array, x 1 second, then check this array, then map.get complement. Okay, okay, so means just basically here they are checking the element that we got in the array, because this will get the same element. Okay, hi, but then this will keep on changing. Okay, then we have this, the time complexity is open and the time space complexity open as well. Here also we can see time complexity is open and space complexity is open, and the total lookup time is open for each element, each of the aberration. So it turns out we can do it in single pass while we iterated and inserting the elements into the table. We also look back to check if the current elements complement already exists in the table. If it exists, we can found the solution and return this. So this is the exact solution what we did. They have a hash map. Going to the length, we calculate the complement, and then for each complement they check if the complement is present in the map that we have built going through the problem, and if it is, then we just return the array with what we got, the complement array in I. So I think there's no, okay, they are returning the complements index first and then their index. What we are doing is I don't think the index matters here, and otherwise they are putting this, we put it in else, but yeah, that is not bad. Actually should, actually no, that is matter, that does matter. We should not put in else. The reason, yeah, it doesn't matter actually. You will return if as soon as you find well return, so it does not matter actually. But in case you would have to find, like suppose count or something, then it will matter. Oh, you could actually get rid of it totally. Oh, that's nice. Okay, so this is this question. There are people some implementations. You can go and check out this. Okay, let's get back to normal. I can check the solution here. Okay, thanks guys for watching, and good night.